So welcome to lesson 3.8. We're going to plot special relations and functions, and we've done a lot of this already. It's going to be somewhat repetitive, but I find if I skip this lesson, I get a lot of wrong answers on the test. So some of it's review, some of it's new, but here we go. This lesson's really about making sure we solidify, we know the difference between different linear functions. So graph both of these on the same graph. So if you're doing a sketch, do them both on the same. So, right, you're finding the slope and the y-intercept, both of these. And the first one, the slope is -5, and the y-intercept is 0, 0. That's why there's nothing there, right? It's y equals -5x plus 0. So I almost did that backwards. Y-intercept is 0, 0. Slope is -5, so that means down 5 over 1. Down 5 over 1. And you can go backwards there. And that's our first one, y equals -5x. All right, so now, the other one looks very similar. But what is it? Well, right, there's no x. Why? Because the slope is 0. Y equals 0x minus 5. The y-intercept is 0, -5. So the y-intercept is 0, -5, and the slope is 0. So that's the graph of a horizontal line. Okay, so really what we're going to add today is graphing vertical lines, right? Notice this vertical line. Look at the domain of that vertical line, right? When we were doing lines that were not horizontal or vertical, domain and range were all real numbers, but the domain there is going to be 5, right? The domain there, no matter where we are on that line, the domain is 5. The range will still be all real numbers, right? We can go all the way up there and all the way down there on y, and we're going to talk about that. All right, so horizontal lines have a slope of 0 causing x to disappear, right? So we're going to graph y equals 4. That means it's y equals 0x plus 4. The slope is 0. The y-intercept is 0, 4. So there's the y-intercept. The slope is 0. That's horrible. Let's fix it. And they're better. No, still not perfectly horizontal. Right, horizontal is perfectly flat. There you go. I'm going to have arrows on the end. So that's what y equals 4. All right. And so I skipped ahead and already plotted it. The slope was 0. The y-intercept is 0, 4. Horizontal line looks like that. There's no x in the horizontal line linear functions. Okay? So there are notes on the next page there. Find the slope and y-intercept and plot the linear function y equals 6. All right, so y equals 6. 0, 6 is our y-intercept. The slope is 0. You can do this on the same one as the last screen if you're doing a sketch. Find, I messed up there because I covered it up. All right, find the slope and y-intercept of the function y equals -9. All right, so let's do that one. So y-intercept is 0, -9. Slope is still horizontal, and those two lines are parallel. Fill in the table for y equals -9. Okay, so when x is 4, y is -9, right? When x is 2, y is -9. When x is 0, y is -9. Oh, my graph wasn't that great, and so on. So y is -9 everywhere on this graph. All right, I missed the line, so let's do it right. There it is. All right. So now let's find the domain and range of the function y equals 6. All right, so we just talked about this. Right, the range, right, which is the y values, are 6 everywhere. The range is just 6. That's it. Right? Y can't be anything else. The domain, right? The values of x can be any real number. You could write any real number. We're going to write all real numbers. All right? For that graph. And you could see that also if you made a t-table. When x is 0, y is 6. When x is 5, y is 6. When x is negative 100, y would be 6. Find the domain range of y equals 9, right? So the domain, similarly, I guess I should do this in red since that line's in red. So the domain of this is still all real numbers because x could be anything, right? X could be over there, x could be over there. And so the range is -9, right? Everywhere along here, the y coordinate is -9. All right, so let's compare these two. All right, this one has a slope of -7 and a y-intercept of 0, 0. This one has a slope of 0 and a y-intercept of 0, -7. Compare these two. This one has a slope of 8 and a y-intercept of 0, 0. This one has a slope of 0 and a y-intercept of 0, 8. Okay, so let's just show this. The one on the left looks like this. It has a slope of 8 over 1 up 8. Now, let me fix that. Up 8. So it's a very almost vertical line. And the other one, the second one, has a y-intercept of 8 and a slope of 0. Right? So this is the horizontal lines. Those are horizontal. These other two go through the origin. Get those straight in your head. Okay, so that gets us ready for vertical lines. Now, vertical lines have lots of exceptions, right? And it's all because of 0 in the denominator. Let's see this. Now, notice, plot the linear relation. These are not linear functions, all right? And we'll talk more about that. They are linear relations, and it's because they don't fit y equals mx plus b. Right? Now, almost anything is a relation. Functions are actually special, and vertical lines are not special. They're not. So let's see that. So the linear relation x equals 3. So on the linear relation x equals 3, the x coordinate will be 3 everywhere along there. All right? That's what the linear relation. So if you did a t-table, the x-coordinate would be 3 everywhere, and it doesn't matter what you put here. The y-coordinate could be anything. And although I was a little sloppy there, I will get to this other one in a second. I'll fix that because I was very sloppy. I was leaning, I guess, and so linear relation is a vertical line. Now, what's going on there, right? There is no slope, right? Because it's undefined, right? It's not 0. And there is no y-intercept, right? It's parallel to the y-axis. The y-intercept is where, right? That's the x-intercept there. That's not the y-intercept. The y-intercept is where it would cross the y-axis, but it will never cross the y-axis. So it has no y-intercept, so it has no b. It has no slope, right, because it's not even 0. It doesn't have one. It doesn't have any of that stuff. So it is not a function. It is not a linear function. It's not a function at all. Y equals mx plus b does not work. All right, so plot the linear relation x equals -7. So there is -7, and we need the vertical line where the x-coordinate is always -7. All right, plot the graph of x equals 5. So we need a vertical line where the x-coordinate is always 5. Fill in the table for x equals 5. Well, when y is 3, x is 5. So you're going to copy this table, please. When y is 1, x is still 5. When y is 0, x is 5, and so on. The x coordinate is 5 everywhere. All right, so what's the domain? So the domain of this one, right, is 5. The domain is 5, and the range is not those numbers, it's all real numbers, right? These are sample points. All right, these are sample points, so it's all real numbers. Right? When it was the points in the graph, it wasn't a linear function, it was just a bunch of points. We'll talk about that in the review. All right, so parallel lines, right, will never intersect, and they have the same slope. If two lines have the same slope, they're parallel. If they're parallel, they have the same slope. So let's get the slope of both of these, right? Over 5 and up 2. Is that the same? Over 5 and up 2. And that's really the definition of parallel, is two lines that have the same slope. If they have the same slope, they have to be parallel. Right? What's different about these is they have different y-intercepts, right? This one's 0, -2. This one's 0, 3. They have the same slope. All right, same thing there. Find the slope of both of those. Hopefully you went down 2 and over 3 both times. Down 2 and over 3, and so the slope of both of those is -2/3. All right, so now we're going to sort of combine things. All right, so how do we find the slope from 2 points, right? We subtract the y coordinates for the numerator. We subtract the x coordinates for the denominator. So, right, so if we do, I'm going to do 3 minus 6 and get -3 for the numerator. So I started here. So I'm going to start with this 3 on the bottom and get 3 minus 1, which is 2. And so the slope of this, you could write it that way, or -3/2. So there it is, right? Here's the point 1, 6. Here's the point 3, 3. Down 3 and over 2 gets you the next point. Notice there is no other line that goes through both those points. There's an infinite amount of lines that go through that point, infinite amount of lines that go through that point, but there's only one that goes through both of these. All right, it's the one. So 2 points, we say, define the line. Right? There are many more points along this line, but all you need is 2. All right, same thing here. Let's find the slope. All right, so let's subtract -5 minus -2, which I believe is -3. I started with -5, so I'm going to have to start with 0 on the bottom. 0 minus -2, and that is 2. Oh, we got -3/2 again. All right, so let's see this one. That's this line, right? There's our 0, -5. In fact, it's y-intercept. Here's the -2, -2. And so they both have the same slope. All right, write a linear function for a line parallel to these lines, right? So these were parallel to each other because they had the same slope. Now you're going to write another linear function, a third one. And this third one is going to be parallel to those. What does that mean? Well, it means it has to have -3/2 as the slope. So the coefficient of x has to be -3/2. And it says this line has to have a y-intercept of 0, 2. So that's the linear function that goes with that. And that one will be parallel to those two and go right through that point in the middle there. Right? All 3 of those are parallel. They all have the same slope. All right, so let's practice. All right, let's find the slope and y-intercept of all of these. Well, let's just say. All right, so the 2 with y equals are horizontal. Right? The y-intercept here is 0, 0. Y-intercept here is 0, 9. This has no y-intercept. And this one is 0, -5. That's how this all works. So which 2 are horizontal? Those two are horizontal. Which one is vertical? This one, right? That's the vertical line. Which one goes through the origin? That one. That goes through the origin. Why? Because it goes 0, 0 as its y-intercept. The other ones could go through the origin, but this one definitely does. Which two are parallel? Okay. Well, they're the ones with the same slope. Which two have the same slope? The two horizontal ones have the same slope. So in this case, I didn't realize I had done that, but y equals 9 and y equals -5 are parallel. They have the same slope, 0 in this case. All right, plot the function y equals -7. So that's a horizontal line. I don't really love this color. Y equals -9, or y equals -7. I'm sorry, we already did y equals -9. There it is. Plot the relation x equals 1. All right, so the relation x equals 1 is a vertical line going through there. Write an equation for each line. Okay, so let's start with the red one since I'm already in red. So this is a y-intercept, right? 0, 5, slope 0. So that's y equals 0x plus 5, also known as y equals 5. The blue one is got x equals 7. Is the only way to think of it. There's no y-intercept, there's no slope, it's undefined, but x equals 7 everywhere along that. The blue one is vertical. The red one is horizontal. And if you couldn't do that, you're not getting an A on this test, all right? There's a bunch of questions about this. All right, the domain, right? The domain, for all the ones that are diagonal, the domain and range are all real numbers, but that's not the case for these. All right, so let's start with the vertical one. The vertical one, right? X, you make a t-table, x equals 7 everywhere. So the vertical one, the domain is one number, 7. The range can be anything, all real numbers. And then the red one, all right, the red one, let's make a t-table for that, right? Y is always 5, right? And x can be anything. So the domain for that one is all real numbers. And the range is one number, 5. All right, I will see you again.